Hey guys, as I've shown in the past, like with this React LED, IKEA has been known for making really good quality products at an affordable price. So it only seemed fitting to take a look at this new SMÅHAGEL 5 volts, 5 watts USB charger. So this retails for just $3.95 and it's probably the cheapest USB charger you can find. First of all, I really like the box. Everything is clearly labeled, so it's 5 volts, 1 amp, so that's 5 watts, and also the voltage and frequency range, and of course it's indoor only. Okay, so let's start with an unboxing. I don't expect to find much in the box, but let's see what we get. Oh, there's even a manual. Look at how much paper. Why would you need so much of that? Probably all the safety thing. Yeah, read, done. Okay, there it is. So at first glance, this looks basically identical to the one that was on sale up until a few months ago for, I think it was like €5 or €6. And if I'm not mistaken, the name was Copla. I mean, it does feel decently built. Like the plastic is fairly thick, the welding is well done. So of course, before taking it apart, I want to put it to the test. So I have here my DC load and an IKEA cable, of course, it's matching. So I'm just gonna plug it in and see what kind of performance we get out of it. So first of all, I'm just gonna check the voltage. Let's see what we get. Should be like around 5.2. It's 5.15, which is reasonable. We're gonna start with a 20 milliamp load. Seems fine. We're still getting 5 volts. Remember, we also have a cable in between, so the voltage is we're gonna have a voltage drop on the cable. Okay, so we're 1 amp, 4.9. Let's confirm that with the multimeter. Yeah, 4.94. That's still reasonable. I don't think we can go much further now. Let's see. 1.2 amps. Yeah, drops down. So as soon as we do 1.2, this drops to 2 volts, which is fairly unusual. I would expect the output to die completely, not just fall to 2 volts as soon as we hit 1.2 amps. So there's going to be like some current limiting circuitry, or we're just tripping some protection inside the power supply. But up until 1.2, it's 1.19, it's fine. That's interesting. If we go above, yeah, it's going to cut it out. Let's see if it returns back. No, it's still dead. Okay. Interesting. Yeah, as soon as we go past 1.2 now, the output drops completely, and if I start it, yeah, now it's 2. That's really odd. Okay, so we know that we can go up to 1.2 amps. I guess this was a fairly quick test. I was expecting it to drop out immediately, which is something that it did before. Like right now, 1.21. I don't know why it drops to like 2.5 volts. But now, you see it goes like 5, 2, and then 0. If I do a 1.20, then it drops down, 1.21, 0. So there is some sort of current limiting that is set at 1.2 amps. Because if I stay just before 1.2, it's still running. And of course, at 1 amp is perfectly happy. Okay, so unfortunately I cannot do much more testing because I don't have a power meter that's accurate enough for such small loads. But for 5 watts, I don't expect anything out of the ordinary in terms of efficiency or power factor. One last test before I get destructive. Here it is connected to my iPhone alongside an inline USB tester. That's a current meter. Don't mind the voltage. This tester here reads a little high. As for the current, we're using 1.17 amps. So that's below the 1.2 limit. I'm gonna leave it here charging for a little bit, and then we'll return back with the thermal camera and see if maybe it overheats. It's been cooking for right about 20 minutes. Here's a thermal camera, and yeah, well, it does get a little bit hot, but nothing too worrying, I guess. It's about 50 degrees. I think that's basically in line with the 5-watt charger from Apple, so I guess yeah, there's not much to worry. Of course, I can feel the heat, but I can definitely hold it in my hand, and it's not melting, that's for sure. So yeah, I guess it's reasonable. It's not excellent, but it's definitely reasonable. Okay, enough of that. Let's take it to bits. I'm gonna try with the trusty vise before breaking out the heavy equipment. It's just 2 sides ultrasonically welded, so I think if we apply some pressure, they're gonna crack wide open. Let's see. Yeah, I like this sound. Yeah, we definitely have a split. That's really good. Okay, we need small flat blade. Let's prise it open. Yeah, that's easy. All right, very basic plastic casing, and also the circuitry looks really basic. It seems like it's like glued in. Huh. Oh, no. Oh, that's interesting. I think they are running, I don't know if the capacitors are discharged. Well, we're gonna find it out very quickly. Yeah, that's actually really nice. So where's the main cap? That's the main capacitor. Let's see if it's charged. It's right here. Across these two. No, it's discharged. So we're safe. Okay. Now the first thing that I really like is this piece of plastic here where the PCB slides in. This basically works as an isolation barrier between the USB plug and the rest of the electronics. So that's really well done. And we also have another slot here. And the primary and the secondary are definitely very well isolated. So on the primary side, we have the plug here. There's a fuse. The fuse is rated for 1 amp, 250 volt. So that's good. We also have an NTC on the other side. They both go into this bridge rectifier, and then just afterwards we have this smoothing capacitor. And then what's next? I kind of get lost from there. Took a closer look at the circuit board, and that's a very simple switch mode power supply. Things I've noticed, the main switcher transistor, it's an NPN 3DD4243DW. That's a 400 volt 2 amp part. The switcher IC, it's this cute little thing here, and it's labeled 2Y3E, and I cannot find anything regarding this part. Another thing of notice is that there is no connection between the primary and the secondary. Actually, there are no optocouplers or feedbacks, so it's purely regulated based on the primary, whatever it's doing. There is very good isolation, as I've noticed before, and on the secondary, we just, which is right here, we just have a single diode, and then we have a smoothing capacitor, some of the resistors for identifying the charger type and the current limit for the device that you plug in, and just some capacitors for compliance, most probably. So that's very, very simple. Of course, that's what you'd expect from a €3.95 power supply. But yeah, that's definitely decent quality. Of course, the capacitors are no name, and there's nothing really too much special about it, but all the safety features are there, and this massive isolation, it's really, really good. So I'm definitely happy with what's inside, and definitely recommend it. So we're gonna do the ultimate test. Let's see if we can put it back together. Shouldn't be much of a problem because we didn't crack anything here in the plastics, so this sits in nicely. And there are also some latches on the other side of the casing, so we should be able to close it quite easily. Let's see. Yeah, really good snap, as you can do on the bottom as well. Not as much, probably because I've bent it a little bit, but we're just gonna run, yeah, we're just gonna use some electric band-aid, and that should fix, should make it compliant again. Okay. I'm just gonna run some at the top here also, just for added safety. And we're done. Here's a quick review and teardown of the new IKEA SMÅHAGEL 5-watt USB charger. It's, yeah, I'll recommend it. Thanks for watching. See you next time.